Okay, well, I'm Janette Lindesay, and I am a climatologist. I studied actually in a geography department when I was at university in South Africa at the University of the Witwatersrand in Johannesburg, which is where I did all my early academic training. And I became interested in studying the climate system, particularly while I was an undergraduate student. So my initial interest in climate science really was centered on an understanding of climate variability. And at the time when I was engaging in my early postgraduate work, the interest was in the El Niño Southern Oscillation, which was very much in the news at the time because there'd been a large El Niño event in 1982-83 that had had serious consequences in Africa. There'd been a widespread drought, and I was interested in studying that as I came along a few years after that had occurred to begin my PhD work. And the work that I did looked at how ENSO was related to drought and above average rainfall in southern Africa and the mechanisms which would bring a signal from the Pacific Ocean across to the African continent. And that's what really got me engaged in looking at low frequency variability in climate. And then I moved on from there more recently, probably within the last 15 years or so, to an interest in climate change. So my current interests really revolve around looking at the interaction between variability and change in the climate system. I've also become much more engaged in recent years in the intersection between science and policy in the climate change area, because it seems very clear to me that while doing good science is essential and publishing that science in the usual ways in the peer-reviewed literature, it's also extremely important that we communicate the science to the public and to the people who make the policies that in the end can make a difference. I'm teaching sessions in the UN-CECAR courses on the basic climate change science. So the first session that I'm teaching is one that deals with weather and climate and how the climate system works in the present day. And I introduce students to basically atmospheric processes and the fundamental driving forces of our climate system and how the energy balance works. And that's a necessary precursor understanding to being able to understand how the climate is changing. I then have a second session where I talk about the science of climate change. And in that one, we look at some of the natural forcings of climate change and also how humans are having an impact on the climate system. And what I'm aiming to do in that lecture is to show students how there's a combination of natural and human factors that are bringing about the changes that we're currently seeing in climate and how these are likely to continue into the future. I also introduce students to some of the basic principles of climate modelling, just enough to give them an understanding of how we can use the climate model scenarios that we have available to us for possible future climate. And I do a session on scenarios and how the scenarios used by the Intergovernmental Panel on Climate Change were derived and how we use them when we're looking at climate impacts work and at climate adaptation. I have another session which looks at climate change impacts. And in that one, I'm drawing on material from my own research, from many other researchers around the world, actually, and also from other academics who have contributed to the CECAR curriculum. In particular, there's material there from the Indian colleagues. So there's quite a focus on the impacts of climate change in the Indian subcontinent area in that particular lecture. So we're looking at substantially weather extremes associated with climate change and the sorts of changes that we expect to happen in the atmospheric system, but also in the ocean, what we're observing today with climate change and then what we expect to happen in the future. So it gives students an idea of the range of impacts that is likely to come in the future and some idea of how much change we've already seen in the system.